A sealed vial containing only benzene liquid and vapor is placed in a Thiele tube, which is then filled with silicone fluid. Heat is applied with a Bunsen burner. As the temperature rises, the liquid meniscus flattens. This flattening is due to the increased energy of the benzene molecules. The forces due to increased molecular movement are beginning to overcome the attractive molecular forces at the surface. At the edges of the vial near the liquid surface, the benzene can be seen boiling. When the critical point is reached, the meniscus disappears and only diffraction irregularities are present due to temperature gradients. Here, the forces due to molecular movement overcome the surface tension and the separation between liquid and vapor disappears. Above the critical temperature, only the gaseous phase exists. A gas above the critical temperature cannot be condensed into a liquid since the molecular attractive forces are dominated by the rapid molecular motion. As the temperature decreases, the meniscus reappears at the critical temperature. The molecules in the gas move more slowly, allowing the attractive forces between the molecules to become dominant. At this point, separate liquid and vapor phases form. Note that the thermometer is present only to indicate increasing and decreasing temperature and an approximate range for the critical temperature.